Let's take a look at a couple of practice questions from Chapter 3 from our textbook. So the first question I chose is calculate the kilocalories for each of the following. I just chose one part of the question. Part A, one stalk of celery that produces 125 kilojoules when burned in a calorimeter. So you're going to need a conversion factor in order to convert the kilojoules. We need to convert kilojoules into kilocalories. So kilocalories is kilocalories like that. And the conversion factor that we could use from our book, it says 1 big calorie, so 1 big C calorie is equal to 1 kilocalorie, which is equal to 4.184 kilojoules. And since we're going from kilojoules to kilocalories, this conversion factor should work well. So we're going to set this up using dimensional analysis. Just going to change the color of my pen here. So if we're starting with 125 kilojoules, we need to multiply this by some kind of conversion factor that has kilojoules in the denominator such that we can cancel our units out like that. And the conversion factor that we can use is 4.184 kilojoules is equal to 1 kilocalorie, like that. Oops, kilocalorie. There we go. And that's all there is to it. We have 3 sig figs in the 125 kilojoules in our conversion factor. We have infinite for 1, and then for the 4.184, we can just assume that that's 4, or yeah, we'll just assume it's 4. So we end up getting 29.9 kilocalories. So there we go. First problem solved. Nothing to it. All right, so let's take a look at another one here. This one's about clam chowder. I grew up on the east coast of Canada, so I know all about clam chowder. Anyhow, so it says here 1 cup of clam chowder. So if we have our chowder bowl, okay, it contains 16 grams of carbohydrates. So I'll just put carb, plus 12 grams of fat, plus 9 grams of protein. And you might have an inkling already that the energy value of carbohydrates, fats, and proteins differs. So if you've studied biology at all, you probably know that fats have more energy per gram unit than carbohydrates and proteins do. So the conversion factors that we're going to use to determine how many kilocalories and how many kilojoules are found in this bowl of chowder. So we want kilocalories and we want kilojoules as well. We're going to do both of those. The conversion factors, I took them straight out of our textbook. So in that bowl of chowder, we're going to say we have 16 grams of carbohydrates, and the energy value of a carbohydrate is 4 kilocalories per gram. So you can see the grams are going to cancel out, and I'm going to end up with kilocalories. Then for the fat, for my 12 grams, the conversion factor I'm going to use for fat is that we have 9 kilocalories for 1 gram of fat. And then for protein, it has the same energy value as a carbohydrate. So it's got 4 kilocalories. Kilocalories per gram, like that. Unless you put 1 gram. Anyhow, you can see how the grams are going to cancel out. So when we multiply all of those, and we can assume that those conversion factors all have an infinite number of sig figs, we get 64 kilocalories for the first one. So that's for our carbohydrates. Plus we get 110. So it's actually only 2 sig figs. If you multiply 12 times 9, you get 108, but we're going to round it to 110 because there should only be 2 sig figs. Kilocalories plus 9 times 4, which is 36. 36 kilocalories. So when you add all that up together, you are going to get energy. We'll just put energy like this. It's going to be equal to the sum of those 4 numbers, which should give you 210 kilocalories, like that. So that's the number of kilocalories right there. And if you want to convert that to kilojoules, we can use the same conversion factor. So if we want to get energy, and I'll just say energy if we want to get it in kilojoules, we're going to say we have 210 kilocalories, and in 1 kilocalorie, we have 4.184 kilojoules, like that. So I'm going to get my calculator out here. I didn't do this one. So 210 multiplied by 4.184. So that gives us 880 if we round it up. So it'd be 880 with 2 sig figs. 880 kilojoules. There we go. All right, so there's using conversion factors to convert carbohydrates, fats, and proteins and determine the number of calories or kilojoules associated with those. Okay, let's take a look at a couple more. So this next one here, you have to know how to convert temperatures. I'm just going to take a look at one here. There's kind of a typo in my question. I don't know why, but when I copied and pasted, it kind of copied the numbers here twice. So I'll just scratch that out. Here it says, calculate each of the following temperatures in degrees Celsius and degrees Kelvin. So we're just going to do this one example where it says the highest recorded temperature in the continental U.S. was 134 degrees Fahrenheit in Death Valley back in 1913. Hot summer. All right, so we want to convert that into temperature in degrees Celsius. So the formula that's found in our textbook is temperature in degrees Celsius is equal to the temperature in degrees Fahrenheit, subtract 32, divided by 1.8. So all we're going to do is plug our numbers in here. 134 subtract 32 divided by 1.8, like that. And we end up getting, just punching those numbers in, we end up getting, what, 57 degrees Celsius. So there's our temperature in degrees Celsius. And the temperature in degrees Kelvin, the way we convert that is we take the temperature in degrees Celsius and we add 273.15. So we're going to take 57 and we're going to add 273.15. And since 57 only goes to the ones place, our final answer can only go to the ones place, so we end up with 330 Kelvin. So there's our temperature in degrees Celsius and our temperature in degree Kelvin. And you should be able to convert from temperature in degrees Celsius into temperature in Fahrenheit as well. All right, so let's take a look at one more here. This one involves specific heat, so namely the specific heat of water. And if you look up the value for the specific heat of water, it's given in our textbook. It says the specific heat. I like to write it SH and then I put a little subscript because we could be talking about many specific heat values for many different elements or compounds. Anyhow, so the specific heat of water is 4.184 joules per gram degrees Celsius. It's also equal to 1.00 cal, so small calories per gram degrees Celsius. So we have to decide which one of these conversion factors we're going to use based on the question at hand. So question 3.84, it says a large bottle containing 883 grams of water at 4 degrees Celsius. Sorry about this copy thing here where it seems to be duplicating numbers for some reason. Anyhow, the bottle of water at 4 degrees Celsius is removed from the refrigerator. How many kilojoules are absorbed to warm the water to room temperature of 22 degrees Celsius? So since we're dealing with kilojoules, it's asking specifically for kilojoules. We're going to use this conversion factor that uses joules. So the formula that I took from our book is that heat, which is the heat that's going to be absorbed, how many kilojoules are absorbed. So we're going to say heat is equal to mass represented by M multiplied by delta T, so the change in temperature, which is the final temperature, subtract the initial temperature, multiplied by the specific heat of water in this case. So the mass of our water is 883 grams. The delta T, again, is going to be the final temperature, 22, subtract 4 degrees Celsius, so that's going to be 18 degrees Celsius, multiplied by our specific heat in joules, which is 4.184 joules per gram degrees Celsius. There we go. So you can see that grams and degrees Celsius are going to cancel out and we're going to be left with joules. So the heat is going to be equal to 67,000 joules. Now again, if you punch this in your calculator, if you punch this expression in the way that I have it written here, you're not going to get 67,000. In fact, you're going to get 66,500, but because there are only 2 sig figs here in this operation, we're going to be limited to 2 sig figs because we end up with 18 degrees there. So this way we report the number with 2 sig figs. Then if we want to convert that into number of kilojoules, we'll just use the conversion factor that 1,000 joules is equal to 1 kilojoule, like that. So joules and joules are going to cancel out and we will end up with 67 kilojoules. There we go. So that's a few questions from the book. I would recommend trying, honestly, I would recommend trying every single problem that you can get your hands on. So every problem in the textbook is worth trying, especially if you have the time to do it. Practice is the best way to get good at chemistry. Anyway, I hope you find these helpful, and if you have any questions you would like me to address, just drop me a line, and I'm happy to take a look at any questions.